Hello everyone, this is the first in a series of videos that I'm going to make describing the Cerberus PUP 170 and how to set up different parts of the hardware and the firmware, make it easier for people who are building these as kits to put them together without a lot of frustration and guesswork, or having to do a lot of research on the internet, because all of this information is really available on the internet, but it's just located in so many different locations it's difficult sometimes to get it all put together. So here we go. This is a Cerberus PUP. You can see it's actually a fairly small printer. This it's a 170 millimeter round bed, and in the bottom of that is an Azteeg X1 by Panacat Devices. It's a Sanguino clone, which is a type of Arduino control board, and I've got one right here which I'm going to show you. It's actually very small, very compact, and a very nice unit. So today what I'm going to show you first is a little bit of information about this board, and then I'm going to show you where you can go online to get the USB drivers for this for Windows or for Mac, for OS X, as well as how to set it up for 16th stepping or 32nd stepping on the drivers, and which pins you can use for fans depending on whether you are running a heated bed or a non-heated bed. In this printer there's a non-heated bed. It's just the glass, and it prints in PLA only, but if you had a heated bed you'd be able to print in ABS and nylon and some other materials, but then you would lose one of your fan outputs, so your fan control is not going to be as precise. So in a non-heated bed, because you can use the heated bed pins for the fan, for one of the fans, you can control two fans independently, which means you can have a part cooling fan and you can have a hot end barrel fan, which keeps the hot end cool enough to run PLA without getting it jammed up in the nozzle, which is always a good thing if you want to have successful prints. Okay, let's get started with looking at some of the software over here. Okay, so first place you have to go is here, reprap.org wiki Azteeg_X1, and there's a section called software there where you can see what you need. You need the Sanguino patch for Windows or for OS X. You need the version 0023 version of the Arduino IDE. Don't install the latest version of this software. Go into the older versions and download the 0023 version. This is very important because that Sanguino patch does not work with any versions newer than 0023. Now, there are some Sanguino patches out there for other Sanguino boards that you might be able to install, but for the sake of this particular system, we are just going to go with the old software. It doesn't make any difference to how you upload firmware to have the newest version. This will work just fine. Okay? So, you may also find out when you plug in your Azteeg X1 that you need the USB driver, and I am actually going to show this to you because when you click on the USB drivers, it comes to this page here, FTDI chips, and you scroll down and you basically choose your operating system over here. Get this right here, and it's got all these drivers here. Well, what you really want to do is underneath the comment section over here, you want to pick the executable. That's really the easiest way to do it, for at least for Windows. 8.1 or just standard Windows all the way through version 7. Okay, so you just click on that, download the executable, install it, and that'll give you the USB drivers, which really make your life a lot more, a lot simpler, basically. Okay, let's also take a look here at the Azteeg X1. So Panacat Devices, I'm going to show this to you here as well. Panacat.com, Azteeg_X1, reprap_3D printer, etc. So if you go to panacat.com, you'll also find information about your board. Okay, so that's a good source of information. Okay, let's go on, and once you've downloaded Arduino 0023, and you should have a copy of the firmware as well, and in this case I'm using Marlin. So you need to have the Marlin files in a folder called Marlin, okay? Or alternately, you need to have the Marlin files in a folder that corresponds to the name of the marlin.pde file. Now, if you happen to get a version of Marlin that does not have a PDE file, there's also a marlin.ino file right there. It's exactly the same file. The only thing that's different is the file name ending, which is PDE versus INO. If you try to open an INO with Arduino 0023, it won't know what to do. So what you do is you make a copy of it and you rename it marlin.pde, and presto bingo, you've got it open inside of Marlin over here. Okay, so Marlin. Let's take a quick look at Marlin. The files that are most important to us are the configuration.h file, the configuration advanced file, and let's just go here. You can see that there's a whole bunch of files that just keep on going across this way, and you never quite get to see, unless you have an incredibly wide monitor, you'll never see this. But down here on this list, you click on that little window, you'll find down here at the bottom pins.h. That's a critical file because you're basically telling, and this is related to the fans and the heater, so you have to know this stuff. You can click on pins, and then it opens up the pins file. Now, this pins file is very complicated. There's a whole bunch of settings in here for basically every board known to man. So, how do you find the pins that you need? Well, inside of the configuration.h file, configuration.h, you're going to scroll down and you'll see that there's actually a motherboard definition here, motherboard 65. Right there, motherboard 65. Motherboard 65 is specifically the ASTIG X1. You can see there's a long list of motherboards here. So you want to make sure that your motherboard is set to 65. Then we'll go back over to pins and down to pins. And if you're at the top of this file, you could scroll all your way down and find a motherboard equals 65, or you can do find. And when find comes up, all you have to do is search for equal space 65 and then do a find, and boom, it'll pop you right down to there, to 65. So there you go. Now we're at motherboard equals 65, and you can see that it's defining ASTIG X1, and there's a couple of changes here that are made specifically for the fact that we use bed leveling, and I think the most recent versions of this are coming out with the bed leveling pin set correctly. But if not, just take a quick look here. So you can comment out define X stop pin. That's two little slashes right there. We'll comment it. Comment out define Y stop pin and the Z stop pin. So those are pins 18, 19, and 20. They get commented out at the top. Then fan pin. If you have a heated bed, then the fan pin needs to be set to 4. If you do not have a heated bed, then the fan pin needs to be set to 12. Okay? 12 is the output for the heated bed. Obviously, if you don't have a heated bed, you're using it for a fan, you can set it to be the fan pin, and the software will turn it on and off that particular fan with that pin setting. Okay? If you set it to 12, you have to come on down. You can see here actually defined ASTIG X1 is set to 12. I'm just going to scroll on down a little further here. You can see that there's a definition for the heater bed pin, and it used to be 12 right there, and now it's set to -1, which disables the heater bed pin, but we've enabled the heater bed pin as the fan pin further up right here. Okay. Now, in order to enable the Z probing, we had to change the definition of the max and min pins. And you can see this little block right here. I'm just going to highlight it. And you can pause on that and just take a look at that. You can see that I've got X max is 18, Y max is 19, Z max is 20, and now there's a new one called Z min pin, which is pin 27, and that's the end stop that we use for the bed leveling probe. Okay, configuration advanced. So why are we in configuration.advanced? Well, you can actually set the original fan pin on this board. It actually has, let's get into the light here. See that? Okay, down here at the bottom where my finger is pointing, right there, there is a set of two pins side by side with a plus and negative. And that's the fan pin, and that's actually pin number 4. Okay? In our situation, what we're going to use the fan pin output for is pin number 4. We're going to use that as a fan that comes on and off when the when the hot end gets above a certain temperature, and it's going to turn a little fan on that blows air across the hot end barrel to keep it cool. Okay, and so the original fan pin, which is the one that you can control for your for cooling your printed part, is the heated bed over here. That's pin 12 right there. Remember, if you have a heated bed, that's the heated bed. You can't use it for a fan. And this is the only fan that you've got over here, which is pin number 4. But in our case, we're using pins 12 for a fan and pins 4 for a fan. This fan here is controlled from inside the configuration _ ADV. Okay? And that's over here. I'm sure you'll have to go over this a couple of times. I'm not the best at explaining stuff. So this one, you can see extruder cooling fans. You can configure the fan pin to automatically turn on and off when the associated extruder temperature is above or below the extruder auto fan temperature. Okay, so here you can see I've set them to 4. We actually only have one extruder on this, but you could actually, this could be -1. It won't make any difference. Okay, but I just set them to 4. It doesn't matter. And I have the fan come on after the temperature has passed 120 degrees centigrade. I get the fan running at 253 out of a possible 255, and that's basically pulse width modulated. And so the lower the number, the slower your fan will turn, up to a point where if you have it running too slow, it'll be so slow it won't even be able to start. And so there's actually something called the fan kickstart time right up here, and this is in milliseconds. So in my case, I just give it full power for a second, and then I could basically turn this down to, for instance, 80 if I wanted it to run really slow, or I could leave it at 253, which is what I'm doing right now. All right, so that's pretty much how you set up your fan pins. Now remember, if you only have fan pin 4, these should be set to -1. Okay, -1, -1. Everything in here gets turned off. The fan pin is set to 4 in the pins.h file, and you do not have a fan to cool the barrel of your hot end. Now you can hook a fan up and just have it running off of 12 volts. So when you turn your printer on, you can get a little fan to just run all the time, blowing across the barrel, but you will not be able to control it based on temperature. And that's because the fan we want to have running is the fan that cools the part. Because when you're printing really, really small detail, you want to have a fan that you can count on to cool your plastic. It's really important to get in order to get good quality. Okay? So let's go on to configuration.h. This is where you're going to find the settings specifically set up for the Cerberus pup. Okay, so remember, motherboard equals 65. That's critical. You have to set that. You can give the printer a little name, like this is a Cerberus pup for my friend Bill. I'm going to give him a printer. He's my machinist. He's a great guy. And Another thing you need to see up here at the top is the baud rate. I set it to 250,000. Okay, this controller works great at a baud rate of 250,000. I don't have to set it down to 115,200. Okay, motherboard 65, and here we go. You might want to just pause on this screen and take a look. I'm just going to tell you what these things are. Delta segments per second. Okay, default delta diagonal rod. Okay, this is the length of the push rods, or the control arms, the effector rods, the ones with the steel balls on the end. In this case, mine are 218 millimeters. The delta smooth rod offset is the distance from the center of the printer to the center of the rollers on the vertical carriages. The delta effector offset is the distance from the center of the hot end, or the center of the platform, I should say, outward to where the ball joints are located. And the delta carriage offset is the distance from the center of the rollers on the carriages to the center of the balls at the carriages. Okay, so all of that stuff gets calculated right here to give you your default delta radius. Now, delta radius is something that we're going to deal with. Actually, all of these. Let's see. Actually, I'll tell you what. Later on, we're going to deal with diagonal rod, and we're going to deal with delta radius. Okay, and those are going to be adjusted during the calibration phase of your printer, so that you don't get a bowing or cupping of your print across the platform, and so that you get the X and the Y dimensions correct as it relates to if you want 100 millimeters from one side to the other, you're going to get exactly 100 millimeters. So it basically adjusts the XY size. Okay, I'm going to keep on going here. For this particular printer, now I'm using a firmware from Marlin firmware that was written by Rich Cattell, and I'll probably put a link to that particular firmware in the description for this video. I don't want this to get too long here. In any case, you can see here you want to set these settings just like they are for a Cerberus pup. Okay, bed diameter 140, auto level grid of 25, and then the Z probe deploy start location is going to be 10, and the deploy end location will be 10. Everything else is zeros except for the Z probe offset, which is 0.6. Okay. Temp sensor is a type 1. We're just going to keep on going down here to get to the good stuff. Well, let's see here. Okay, so you power on your printer, you burn the firmware, and you hit home, and the darn thing heads down towards the bed instead of away from the bed, up towards the end stops. Then what you've got is your wires on the stepper motors are different than what I've got, or different than what is set up in the firmware. So here's where you can change the direction of the stepper motors. So invert X direction, true or false. Okay, so if it's going down and it's set to true, and you want it to go up, just change this to say false, and it'll flip it around and it'll go the other direction. The same applies for the Z, the Y, and also for the extruder. If you start to extrude filament and it's actually pulling pulling the filament out of your nozzle away, then just flip that around from a false to a true. Okay, but for a pup, these should be set up this direction. Okay, home dir is set to 1. That basically is the max. It pulls the home direction away from the print bed. Okay. The other thing you want to set right now is the manual Z home pause. That's the position. Basically, this is the height of your printer. This is going to vary slightly from printer to printer, and it really depends on how you have those end stop screws screwed in or out. But for now, we're just doing rough setup. We're going to do a full calibration of this printer from Repeater Host. And all of these settings that I've just showed you, for the most part, can be adjusted within the EEPROM settings. Okay. So, moving on, I have my printer's controller set to 30-second stepping, and that's what we're seeing right here. Steps per unit is set to 160. Now, I use a 20-tooth pulley, and I use 30-second stepping, and that ends up being steps per unit of 160. Okay. I'm going to show this to you real quick. Underneath the stepper drivers, now these are the stepper drivers here, there are some jumpers, and I've got one set up here for 30-second stepping, and I got one set up here for 16th stepping. Okay, you want to have them set to 30-second stepping. I just find that it runs a lot quieter that way. And there you go. You can see it's jumper, open, jumper, and there are 3 jumper spots underneath each one of these. So 1, 2, 3, 4 of them, and you have to have the jumpers set up MS1 jumpered, MS2 open, MS3 jumpered. Okay, actually MS3 is over here. And if you wanted to run 16 stepping, you could just do MS3 jumpered right there. That's right. Yeah, M3, MS3, something like that. Anyways, you can see it right there. The other thing that I do, gosh, I'm going to break the board. I'm trying to get it so you can see it here, is there's another little jumper right over there. That basically switches from internal power to USB power. So I like to have my board not be on when I have it plugged into the USB cable, so I switch that to the INT side, not to the USB side. You can see, I'm sorry, the light's just not very good here. You can see what side it's set to right there. Okay? Okay, so onward. We've got to burn ourselves some firmware. And I've made some changes here, let's just say. And if you look at the top of the screen, there's a whole series of these little buttons across the top. One is save and one is upload. Those are the 2 that I use all the time. So if you see a little weird squiggly shape there, that's got some symbol, means something. I don't know what it is, but if you see that there, then that means that you've made a change. You need to save it again. So I'm just going to hit the save button, and you'll see that it goes away. So we've made changes to configuration.h. We made a change to pins.h if you've got fans or hotbed. And now it's time to do the upload. Well, first thing you have to do is you've got to go to board, and you've got to pick ASTIG X1 with Atmega 1284 at 16 megahertz. Okay, and when you come down here, you can see now that it's got a little checkbox next to it. And the next thing you have to do is you've got to come to serial port. This is done after you've installed those drivers from the wiki page and followed all the instructions over there on how to get that Sanguino patch into Arduino 0023. It's all described over there, so I'm not going to show you how to do that. But basically, your computer pretty much always has a COM1. Don't pick that one. Pick whatever other one you've got. It may not be COM11. It could be 3, 4, 5. And at that point, as long as you are not connected using the Repeater Host software right here, I'm going to disconnect the Repeater Host. If the Repeater Host or your host control software has taken control of the COM port by being connected to the printer, you will not be able to upload using the Arduino firmware. Okay? So at this point I'm going to hit upload, and you'll see down at the bottom there's a status. It says uploading to I/O board, and actually it's probably one of the things they changed in later versions. It should say compiling here. Okay? And then you might hear something happening over here on your board. And let's just take a quick look here and see if we can see the little lights going. And you can't. You can see the lights going. They're over at the front of the board right there next to the USB connector. So on this one, there's your USB connector, and there's the little 2 lights, TX/RX, and those are going right now, so you can see them flickering on and off down there. Okay? So it's uploading. We're making whatever changes we made, and those are going to the system right now. And that is how you burn the firmware. Okay. We'll just wait here. It should be finishing up in just a moment. And I'll show you what that shows. There, it says done uploading. Okay? It's done. Alright? You can come back over here. You can hit connect. And I'm going to hit the home button over here. Everything's working properly in that respect. And that's all for this particular video. Thanks for watching.